The question is, evaluate the integration of this function x plus 2 upon square root of 4x minus x square with respect to x. Now to solve this question, first of all we take the given integral and we see that it is in the form of a linear expression upon a square root of a quadratic expression, right? So these types of questions are solved by taking the numerator, that is x plus 2 is equal to lambda times d upon dx of the quadratic term in the square root sign plus mu, like this. X plus 2, that is term in the numerator, is equal to lambda times the d upon dx of the term that is a quadratic expression inside the square root sign plus mu. The differentiation of 4x is 4 and x square is 2x. So I'm going to get the expression like this. I mark this as equation number 1. Separating the constant and the term of x in equation 1, I'm going to get this x plus 2 is equal to 4 lambda plus mu minus 2 lambda x, right? On the left hand side, the term of x is this and the coefficient is 1, and here the coefficient of x in the right hand side is equal to minus 2 lambda. So I can write, that is on comparing the coefficient of x, I can write 1 is equal to minus 2 lambda or lambda is equal to minus 1 by 2. I can mark this as equation number 2. Similarly, the constant term on the left hand side is 2 and on the right hand side is equal to 4 lambda plus mu. On comparing them, I am going to get this as equation number 3. I am going to place the value of lambda as minus 1 by 2 in equation number 3 to obtain 2 is equal to 4 times minus 1 by 2 plus mu, or 2 is equal to minus 2 plus mu, or 2 plus 2 is equal to mu, or mu is equal to 4. Now I'm going to place the value of lambda, that is minus 1 by 2 in equation number 1. Similarly, mu as equal to 4 in equation number 1 to obtain this equation number 1a. Now the value of x plus 2 is going to be substituted from equation number 1 to make this integration solve. Okay. So taking the integral and placing the value of x plus 2, I'm going to get the integral like this, and dividing, there are two terms in the numerator, so dividing this denominator separately by these two terms, I'm going to get these two separate integrals. I'm going to mark them with I1 and I2. This is done because both the integrals are going to be solved by some different method and the substitution would be different. If I could have solved them directly or by direct method, I would have not named them I1 and I2, right? So taking I1, now to solve I1, what I see here is this, that on differentiating 4x minus x square, I get 4 minus 2x, right? So on substituting 4 minus x square is equal to t, differentiating both sides with respect to x, I get 4 minus 2x dx is equal to dt. So 4 minus 2x dx is replaced by dt, and this 4x minus x square, I'm going to substitute t. So I'm going to get this as minus 1 by 2. This minus 1 by 2 is written outside the integral sign. I'm going to get minus 1 by 2 into integration of 1 by root t with respect to t. Okay, this can be written as minus 2 t to the power of minus 1 by 2 dt. On integrating, I'm going to get this as minus 1 by 2 as it is, t to the power of minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. This is done by applying the formula for integration of x to the power of n is equal to x to the power of n plus 1 upon n plus 1, right? So this gives me 1 by 2, 1 by 2. So I'm going to obtain this minus 1 by 2 t to the power of 1 by 2 upon 1 by 2. These two cancels out. That is minus root t, or minus 4x minus square root of 4x minus x square. So this is the value of I1. Now taking the integral I2, we see that this integral has a quadratic term inside the square root sign, right? So I'm going to simplify this term inside the square root sign, that is a quadratic term, and write it as the sum or the difference of a square of a variable term and a constant term, right? So taking 4x minus x square and taking minus sign common, I'm going to get this as minus of x square minus 4x. So inside the bracket, the coefficient of x square is 1 and the coefficient of x is minus 4, right? Now, the coefficient of x is minus 4, and I'm going to neglect the minus sign. Divide 4 by 2 to obtain 2. I'm going to now add 2 square from this expression and subtract 2 square from the expression to obtain minus of x square minus 4x plus 2 square minus 2 square. So these three terms can be written as x minus 2 whole square minus 2 square, right? So this is equal to minus of x minus 2 whole square minus 2 square. This expression would be written instead of 4x minus x square to obtain the integral I2 as equal to 4 upon square root of 2 square minus x minus 2 whole square, right? Now to solve further, I'm going to substitute x minus 2 as equal to t. Differentiating both sides with respect to x, I obtain dx is equal to dt, right? On substituting dx is equal to dt and x minus 2 as equal to t, I'm going to obtain I2 as equal to 4 upon square root of 2 square minus t square. I know that integration of 1 upon a square minus x square dx is equal to sine inverse of x upon a. So this can be written as 4 times sine inverse of t upon 2. Placing t as equal to x minus 2, this will be equal to 4 times sine inverse of x minus 2 upon 2. Okay, now since we have solved I1 and I2 and the given integral was x plus 2 upon square root of 4x minus x square dx, this we have written as equal to integration of these two terms, that is I1 and I2. Placing the value of I1 and I2, the value of integration of the given function is equal to minus square root of 4x minus x square plus 4 times sine inverse of x minus 2 upon 2 plus c, which is my required answer. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.